I found on internet this article predicting breast cancer using Apache Spark machine learning logistic regression. And I want to show you how we can use this particular case or example to make any other similar prediction. From this site, I downloaded the data and the program and installed it in my PC computer at home and, and try. So you can do the same if you want. Maybe the most strange term here is logistic regression. So let's see what is logistic regression. Logistic regression is a very popular method to classify things into groups: true or false, yes or no, positive or negative. These values will be treated as zeros or one. Some examples of this classification are: a tumor is benign or malignant, a patient has a particular disease or not, an email is a spam or not, a credit card transaction is fraudulent or not, is this A or B? But logistic regression is only one of the many algorithms or methods using machine learning to tackle different kinds of problems. As you can see here, we have different groups, big groups, anomaly detection, that is really another classification, clustering, multi-class classification, regression, and two-class classification, and here we can see the logistic regression. All the algorithms or methods that we saw in the previous picture require data to do their job. Without data, it's impossible to do any prediction or classification or whatever you want to do with a machine learning algorithm or program. The selection of the right variables is very important. We can see here in this example variables that are all medical terminology that we don't understand, but clearly there is no one that is the sex, for example. Sex is not involved because cancer in men is really rare, so it doesn't make any sense to build a model to predict cancer in men, but in women, yes. So all of this data is collected on women, not in men. So that's why sex, for example, is not included. To be able to make a prediction, we really need to find a function to calculate y based on some x variables. But how to find that function? I'll change the breast cancer example for an easier to understand this one. That is the price of a house based on the size. And you can see here we have in the x-axis the size of the house and in the y-axis the price of the house. And we have some blue dots that correspond to the collected data regarding the size and the prices. So the function can be something like this one, right? So where we are going to find, what we have found is a boundary line. But there are many potential lines, so how we selected this one in particular? To show how to select one of the many potential lines or boundaries, we are going to simplify one more time the problem to find the line between 3 points instead of so many that we had in the previous picture. So we start with a random line, this is the random line, and calculate the error of each point, where the error is the distance between the line and the point, okay, this red line. So we have 3 errors. The error of a line is the sum up of all the errors of each point to the line. So we are getting this big red line at the sum up of all the errors in that line. We then create another line and calculate the error again, and in this occasion the error are those yellow lines. We calculate the error of the new line as this large yellow line, and as we can see is larger than the previous one, so this is not the right one. We need to go then in the opposite direction, right? So we move in the opposite direction and we draw a new line again and calculate the error of each point, and in this case we have those green lines. Calculate the error of the line and we get this new line, and this is less than all the others too, so this is a good candidate. So we continue until the error is minimized. To avoid negative distance, the distance are power of 2. This method is called gradient descent least squares. The complexity of the function can be go from simple, very simple, or underfitting to too complex or overfitting. So most of the algorithms that they are going to try to give you is just right. And the different algorithms have some parameters to influence the simplicity of the solution. Underfitting means that the solution is too simple. Just right is just right, and overfitting is not good because it's too complex, and in general is just memorizing the solution, and that's not good. That's that we are not looking for. We just saw that not all solutions are linear. So as we are seeing here, these are two solutions that are non-linear. In the left side we have a circle, and in the right side we have two straight lines. But we can try to not overfit. Remember, we must avoid to overfitting. So sometimes we can transform these functions in, for example, in linear functions. In the left side, we can draw a small triangle here, and we can say that the distance from the center of the circle to this point is the function. And in the left side, we can say that all those values that are at the left side can be moved to the right side. How can we do that one? With the absolute value of the x, and here with the distance to the center of the circle. So we can calculate new variables with these two new formulas and have a linear function. Here the distance to the center of the circle, and this one the absolute value of x. Now you know how the function is calculated. And we have said that the functions depends on variables, right? But in machine learning, the variables are called features. And in the breast cancer example, we have these features. Below, we can see here another example that we have used previously, predicting the price of a house based on the size, but new features have been added as number of bedrooms, number of floors, age of home. Now let's talk about label. As you can see here, it has a yellow background color. So we have the two provided examples, we have this column that is treated as a label, and in the second example, this one is treated as a label too. Label means is the real classification done in the data that has been provided to the model, to the program. So in the case of the breast cancer prediction, this column is telling us if the tumor was benign or malignant. And in this other example, he's telling us the price of the house. So when the data comes with a label, it's called supervised learning. When label is not provided, it's called unsupervised learning.